Hello, everyone. This is Pratyay Banerjee, a student of computer science at UIC. And this is the second part of the project for CS441, Engineering Distributed Objects for Cloud Computing course taught by Professor Grechanik. And in this project, we are creating the large language model decoder using Apache Spark. So in the first part, we created the encoder, and in this part, we are creating the decoder. So what we have done in this project is in the first, we have created sliding windows from the tokens that we generated in homework one. And then from those sliding windows, we at first generated the token embeddings that was done in the homework one. Here we have taken that code and used that same code in the project in this project. And we have additionally calculated the positional embeddings of the sliding windows and then added the positional embeddings to the token embeddings. And we have created a data set of input and target embeddings. And then with this data set, we have trained a neural network model that can predict the next token. If we take a look at the code, this is the sliding window util class, which is the class that there's the main method and most of the tasks, like all the tasks have been done. So first, we are creating the Spark configuration, and then we are reading the tokens in this all tokens array. That is the tokens that were generated in homework one. And then from those tokens, we are getting all the token embeddings. And then we are broadcasting those token embeddings so that all the worker nodes can have access to those embeddings. And then we are creating the sliding window for those token sliding, like those tokens. And then for the sliding windows, we are storing those in RDD, obviously, because that is the data structure for Spark. And then for each of the sliding windows, we are calculating the positional embeddings. And then we are adding the positional embeddings to the token embeddings. If you see here in the input embeddings, we're adding the positional embeddings. First, the input embeddings has the token embeddings, which were created as part of the first step, like when we generated all the token embeddings for those tokens. And then in the next step, we are calculating the positional embeddings and we are adding it in the input embeddings. And then we are forming a data set of the input and target embeddings. And then we are just creating the training master. And then we have like training the model basically with the data set. So this is basically the code. Yeah, this is basically a brief overview of what we have done in this project. And let me show at AWS how we have built and deployed the project. So first, let me show this LLM. So I've created an LLM like a bucket which will store the input file, like the token IDs.txt. This is how the token ID.txt looks like. It has the tokens of the wiki train file, like the data set, and this token ID file was generated as part of the first project. And then this is the jar that we have, like the type jar that we have uploaded in S3 bucket. And we will be using HDFS for writing the output files. And yeah, let's go to the cluster. So this is, uh, yeah, so this is the cluster that I have built. You see, this is my cluster. And here we will add a step for our Spark job. So here we'll select Spark application. We'll select Sparking. We can give any name, Spark LLM job. And then here we will have to give the jar location, which we have uploaded. And here we'll have to provide the commands. So like which class needs to be run and those type of details like the executor memory and driver memory. And here the arguments. So token IDs.txt. So what I wanted is like I wanted to use HDFS only. That's why like from S3 I've shifted the token IDs.txt file to HDFS. So if you let me just show it here. So, so if you see, there is this token IDs.txt file in the input Spark directory. This is the directory I've created on HDFS EMR, and it has the token IDs.txt files. And these files are the temp files that Spark generates from the previous runs. Yeah, so these are the temporary files from the previous runs. And this is the token IDs.txt file. So now what I'll do is I'll add the step. So as you guys can see that this is the Spark LLM job that we just step that we just created, and it is now in pending state. So I'll wait. It will take some time, and so I'll wait for it, and then I'll resume the video. So as you guys can see that the job has completed successfully. And what we are expecting from this job is like it will create two things. One is the statistics file that we expect as the output of this job. And the another thing is a zip file, that the zip of the model that has just been trained parallelly using Spark on the data set of input and target embeddings. So, and I've configured this job in such a way that both of these things will be written to HDFS. So we'll take a look at EMR's HDFS. So I have given the output path as input Spark, and there in the input Spark directory, it will get created. So let's take a look if it has been created or not. So yes, it has been created. As you guys can see that these two things have been created. The training model, uh, the train model zip and the training metrics.csv. And if we try to take a look what is inside the training metrics.csv, so yeah, if you can see that this is the training metrics.csv, since we have opened it in the terminal, it's a bit difficult to understand, but these are the headers. So for each epoch, we have the metrics. So this is the epoch ID, and then there's the timestamp, which is the duration for each epoch. This is in milliseconds. And then the training loss, training accuracy. So these is the training loss, and then the training accuracy. Like for some, it has been 0, and for some, it has been 0.125, 0.375. These are the training accuracy. So how we have calculated the training accuracy is we have predicted the correct predicted tokens. Like we have calculated the correct predicted tokens by the total number of tokens. So here, let me just show it. Here there is compute accuracy method which calculates the accuracy. So it predicted token by the total number of tokens. That is how we are calculating the accuracy. So we are finding the predicted token by calculating the nearest similar embedding vectors, where we are calculating the close cosine similarity of the output embeddings with the token embeddings that are there. And then that's how we are predicting. So yeah, that is the training accuracy. And then We have the gradients and the learning rate, the Adams learning rate, and then the Spark rated matrix, like the memory write, like total, sorry, memory, the total shuffle read bytes and shuffle write bytes, the maximum task duration, and all those things have been there in this training metrics.csv file, which is there in HDFS. We can also view similar kind of metrics through the UI. And here, if you see in this AWS UI, if we go in our application, this was the application that was just run. Uh, and here we can see the task that has been run, like how much this task has taken. There's around 806 jobs for this particular task. And we can take a look at the different stages, how much each stage has taken, and how the shuffled right and the shuffled read, sets of shuffled read and shuffled write metrics. And and the executors also we can see how much memory, the RDD blocks, the storage memory, disk use, all those kind of the task time. So this is the kind of the metrics that the Spark UI shows. So yeah, this is basically it. We have trained the model, and we will be using this zip in the next homework, that is homework part 3. So yeah, that is it. Thank you, and please let me know, like please post any questions if you guys have any doubts on anything. So yeah, thank you.